Hey guys, welcome back to Computational Biology Python. As you can see, I'm in a new locale, so I'm hoping my laptop is up to the task because my desktop is kind of my powerhouse that does most of my videos. So if my video gets a little chunky, I apologize. Hopefully the audio is still good. And if anything, I think that the video recording of me might be a little messed up, but everything in the screen capturing stuff should be fine for you guys to be able to continue to work here. Let's see, let me make sure I got this big enough for you all. You have to bear with me. Okay. So, whoa. A little too big there. Let's see here. Okay. I hope that works. Alright, so first things first, I had an issue starting this video with having my OpenCV not work, so if you have that problem, you have to go to the terminal and do Python pip install upgrade pip. Pip is like an installer. So you want to update that. Mine says it's already, yours might take a second to run. Mine, I already did this troubleshooting. And then you want to do pip install OpenCV Python. And it says it's already installed. But those commands should get OpenCV loaded for you if you're having an issue like I did. Okay, so I'm in my files. I'm going to save this as we'll call this one object tracking. Okay. Well, actually, this is no, not object tracking. Let's rename this to, we're off to a great start today doing this. This feels so out of place here. That's alright. Object detection. So that's a better name for it. Okay, first things first, import CV2. Fingers crossed this works. Yes. Okay. Next thing, we're going to import numpy as np. Good. Import matplotlib dot pyplot. Where my cursor go? Dot pyplot as plot or plt, and then matplotlib inline. Make sure you put the % sign there. Okay. So we're going to try to have a detect objects in an image, and so the way that we're going to do this, I'm going to go to Google, and this is kind of experimental because I'm not going to use, I want to kind of stick with the theme of this course when I talked about object detection as a phenotyping tool. So we're going to do sunflowers, or I'm going to do sunflowers. You can do whatever you want for your detection, but I've already downloaded two. I've kind of vetted what I wanted to do, but what you need is a training and a testing set. So let me show you what I downloaded. Oh, I'm probably not even showing this because it's probably still on. Yeah, the way I'm capturing is there we go. Okay. Oh, it's showing it. Good. All right. So, I picked a single sunflower picture that is going to be my training set that OpenCV is going to look at, and it's going to be like, okay, this is what I am supposed to look for, and then it's going to have a searching data set, so like a field of sunflowers to identify. So once you download those, you want to make sure they're like JPEG images. Is going to be easiest. I'm going to upload them. So I have. So here are my. Can you see that? Oh, you can't see it. I'll load them and I'll show you what they are. So is this gonna let me? Oh, let's see where to go. Sunflower. Training sunflower. Okay, so this is what I picked for training. And then for testing, I'm going to upload this one. And this is my testing photo. I'm wondering I hope that since they're different sizes, it's going to work. Because like I said, we're kind of playing around with this. So I'm going to say full equals CV 2.imread. And so I'm going to load my testing, sunflower testing. I think I capitalized testing. Testing.jpg. Good. Okay. And then I got to change the color, remember, for this. cv2.cvt color full cv2 color bgr to rgb. Okay. And then plot imshow full. So this should show my picture in the right colors. There we go. All right. Oh wait, wait a minute. Oh, I wanted training. Not testing. Okay. So I'm gonna have to run these commands again quick. Did I run this too fast? I'm gonna have to change this full to, probably because it's already saved in memory, so it's probably not gonna like. Oh, why did it work the first time? Is this not a JPEG? It is JPEG. Oh no, that's alright. Testing. Where's training? Oh, it's training sunflower. Oh my gosh, training sunflower. Alright, let's change this back then just to full. Okay, now this should work. There we go. Plot image full. There's my training guy, perfect. Okay. So now we want to also upload the testing. So we're going to do we'll just call this test equals cv2.imread. We're going to call this sunflower testing with a capital T .jpg. Oops, double clicked there. I'm just going to copy this and I'm going to paste it here, but I'm going to call this test. So I'll have to type it all out again. So this, remember, converts it to the right color. Now plot.imshow test. Okay, so that's our testing. So we're hoping to identify this region with our sunflower. We'll see. Okay. So now what we want to do, let's do print full image shape, and then we're going to say comma full shape, and then we're going to print this we'll call test image shape, and this will say training image shape, and we'll say test.shape. Alright, let's run this. Okay, as you can see, we have quite a big difference in the sizes. So we're hoping we still detect it. Otherwise, we might have to use the standard thing. Alright, so methods equals. So there's different methods, and they're just different algorithms. I'm not going to talk about how they all work because I'm not a mathematician and it is out of my area of expertise, to be honest. But we're going to try a few different ones and see which one gives us the best result. CV2 TM CCORR. Oops. Yeah, you're going to have to bear with me typing on this tiny laptop keyboard too. CV2.tm CCORR. If you want to know, try to get into like the math of this stuff, if you're like a junkie for it, you can just Google these commands and it will come up with the documentation. But like I said, I'm not going to get into, it's all like matrix theory and stuff that's above my head. SQDiff, normed. Alright, then end bracket. Okay, so we saved into a variable all of our methods, or all of our different methods that we're going to try, right? So now we're going to write this loop for m in methods, and then we're going to create a copy of the image, full copy equals, oh no, we want, what do we call it full? We called it test. So we have test copy equals test.copy, and then method equals eval m, and then we're going to do for our template matching, we're going to do res equals cv2.match template test copy, and we're going to do it with, oh wait, no, we want, yeah, then we're going to do it with, what do we call our training data set? Oh wait, hold on, I should have named these different. Alright, so yeah, so full is what we want to, is our training, so we're going to match it with full and then use one of our methods. So what this is going to do is it's going to try to match and draw a heat map around the closest kind of distribution of pixels. So we're going to do min val, max val, min loc, max loc equals cv2 dot min max loc for res. Okay, now we want to draw the rectangle onto our picture that it's matching. So let's do if method in cv2.tm sqdiff cv2.tm sqdiff normed top left equals min location, else top left equals max location. So that's just because the way those two work, we have to define that the top left is the min location, but for all the other methods, the top left is the max location. So we just have to kind of specify that for purposes of this. So for the bottom right, we want height, width, channels equals full shape. Then we want bottom right equals top left 0 plus width top left 1 plus height. So we're saying, okay, use that top left, and then how big the box is that we're drawing. We want to add the width and the height, right? So we're starting at the top left. So this would be your top left. You're looking at me, I think. But my camera's flipped. I don't know. But we're saying, okay, take this spot and add this much height and this much width, right? Okay, and now we want, let me scroll down for you, cv2.rectangle full copy top left bottom right, and then we want 255 0 0 10, so the size of our box. And now we're going to plot. So for a plot, we're going to plot dot subplot 121 plot dot imshow res plot dot title heat map of template matching plot subplot 122 plot imshow full copy plot dot title detection of template or test, right? And then we're going to add a title with a method used, so plot subtitle M for whatever method we're using, plot show print N, so this just gives space between the plots, print, and it means new line, so it just gives us some space. Okay, so fingers crossed. Error, let's see, width is not defined. Alright, what line is that? 16. Let's see. Oh, width. Now it's not defined. Full copy is not defined. What did I didn't call it full copy, did I? Test copy. This is what happens when I change the examples, is I get some stuff mixed up. Full copy is not defined. Where else do I have full copy? Oh, test. PyPlot has no matplotlib, but PyPlot has no attribute subtitle. What is it called? Oh, subtitle, supplemental title. Okay. CD is not defined. We're getting close, so we got one. equals eval m. So what is it telling me again? When my error? C2 match template for m in methods. Oh, did I maybe spell something wrong? Oh, this is supposed to be CV2. That's the problem. Okay, so my methods were messed up there. All right. All right. Okay, so we have one method. The problem is, I wonder, my image is so small that kind of made this a little bit of an error. But you can see, so what it does is, all right, first it takes your input image. So if you remember, this is our input image. And then it makes like a heat map of like the pixels, right? So you can kind of see this is like a very weird, kind of trippy version of that sunflower picture, where you see we have a dark spot in the middle, we have bright spots beneath, right? And then it tries to find that same kind of distribution of pixels in this image. And as you can see here, our box is kind of messed up because this is really small. We should have changed our plot size, or our box size maybe. Or what I really should have done is picked a bigger image to try to detect. But you can see that we've identified in this image, it's kind of a big box, but the detection of the sunflower head, but none of the other ones really. Oh, we're missing one because this is messed up over here again, I guess. Yeah, CV2. Let me fix this and we'll run it again so we get the last method. Yeah, so it looks like, what? Did I not run this? Yeah, the last ones didn't work either. But, so part of it too is, quote unquote, garbage in, garbage out. And so for the example that was, that came along with this like lecture, all it did was it took an image crop of a dog, cropped out the face, and then matched that face back to the same thing. So that's not really useful because you've already found the face to start with. So we wanted to try to train with a different picture. So if I were to do it again, or if you want to try to do it, what you would want to look for is a sunflower picture that is larger than the one that I did. So I don't know, are you being able to see this stuff right now on the thing? Yep. Okay. I don't know, so maybe something like this, although you kind of want it to be kind of similar. But for the utility of this, so you might be thinking like, oh, what's the point, right? Well, like I said when I did the intro to this phenotyping stuff, if you can, because you have this drawn on box, you have the location of that sunflower head, right? And we just trained it with a one sunflower. And what you can actually do, we're not going to get into it, but you can actually aggregate. So if you have like 50 training photos, you can use like machine learning to find what's in common of those 50 photos, and then it will just look for that in your testing data set. So you can make more robust training data sets. We just picked one photo for our training data set, and so it isn't super robust. But going back to my sunflower conundrum when I kind of introduced this topic. So if I wanted to use a method like this, what I could do is I could take a whole bunch of photos of sunflower heads that I wanted to measure. And then I could train my training data set to find the commonality between all those, like the overlapped heat maps over all those pictures. And then I could run a loop to say, okay, look at all these different photos and tell me where the sunflower head is. And if I do a time series of that sunflower movement, I have that red box drawn, right? So I can measure where the red box goes, and I can measure the angle of the sunflower based on where that red box is, right? So I could automate this. And so when I was doing this project, we had a field, I don't know, we had 200 varieties of sunflower, and then we had triplicate at least growing of those sunflowers. So we had 600 different plants, and then you had images taken every 5 minutes or something like that for days. So you have thousands of pictures, right? So if you can automate the measuring of this movement through something like this, then that is a huge upgrade and ability to leverage your time. And the other thing too is that, like, say you want to try different methods. Like if I measured the sunflower heads one way, then I was like, well, maybe we should have measured from this point instead. Then I have to go back and remeasure them all. But this way you can try different methods and stuff like that automated, and you don't have to spend weeks doing it. So that is it for this video. I hope, I'm sorry it wasn't the ultimate brain explosion of, wow, look, we really identified it, because we did partially with one method, the CCORR NORMED method, but you can get the utility, and if you want to look more into this, you kind of have a basic understanding, and so you just have to look at how to like test, make better training data sets, and like I said, garbage in, garbage out. So if you don't have the greatest picture, find a bigger picture than I did, and go from there. So thank you for watching. I hope my video turns out okay, because like I said, you can see I'm in my father-in-law, awesome, he has a really nice pole barn. it's really nice, but it's still, it's not home. But yeah, thanks for watching. I hope you learned a little something. If you're watching on YouTube, please hit like, please hit subscribe, and I'll catch you in the next video.